Hello and welcome to this tutorial about the I/O example. In this video we're gonna do something special. So we have a Pi here, it's running ABMT with the GPIO example, and let's show it to you. Here when I press this button, you see in the scope that here in the scope you see that I'm receiving an input, and when I change this parameter, the LED goes on and off again and on. So today I said we're gonna do something different. We're gonna stop ABMT here on the Pi and we're gonna connect remote. So here we go. We are on our notebook here, calling SSH. This is for port forwarding the GUI port. So now we are on the Pi. Start ABMT as before. ABMT 15, like always. ABMT example workspace IO GPIO. So, and we start with the parameter no GUI. So it's only starting. And here we start at our notebook, our GUI. So ABMT 15 GUI, ABMT GUI. Basically, you do the same on Windows when you have the GUI installed. Yeah. So let's press play, look at the view. I press the button, turn on and off the LED. You don't see it, but it doesn't matter. What we look, let's look into the model. Here we have a GPIO output. This is the configuration, pin 10. Here we have an input, pin 11. Let's combine them. Now the LED should go on when I press the button. So looking at our GUI first. Button pressing works. Now let's look here. So that's basically it for the input and output. And now let's look into I2C. So we stop ABMT here, we start our I2C example. So here we go. Start the GUI once again, closing wasn't necessary here. Start compiling, look into the view, we have a scope. We look into the model. Here we have the I2C device. Here I can configure the device I want. Here we have a sensor. So now let's look into the source code here. Basically what this node does, it's providing a pointer to an I2C bus, which is implemented here. And the main function that needs to be implemented is this one, read and write. Here's the implementation. I think when you're interested, you can look into this. It's very straightforward. So let's look into our sensor here. Here we have as input this pointer. Here it is, the include for this pointer. So the implementation can vary. You can use GPIO for instance, to have an UDP, to have an USB I2C adapter. Here you can write and set up your device. When you're familiar with I2C, then this should be no problem for you. Here we configure the device, here we read some data. Okay, so now let's look into our view. We have started already, so here we go. Here's our small sensor we have here, so what I've done here. So let's go back. This is the accelerometer. Oh, I don't know how it's called. So, and here we see that's what I did last time. So 1, 2, 3. 1, 2, 3. So now let's go crazy. We stop it here. And what we want to do now is we adjust this a bit. We want to send this accelerometer data to another computer, in this case to this laptop here. So TCP/IP, let's send this. We need serialization. And because it's a stream, we want to pack this into stream to packet. So here we go. There's something I don't like at the server node, is that it's only listening to localhost. We change this to any. So let's see how that works. We are ID 100, that's default ID. So while this is compiling and already running, so this is good, we start a new ABMT version here. Instance, so ABMT 15, ABMT, and example workspace IO demo. New configuration. Okay. What's wrong? It needs some time for the second GUI, so now let's start another model here. Demo. Let's add some client. Let's add the serialization, encode, decode. We need to decode our stream because not the complete content will be delivered in one tick. So this needs to be decoded. So now we need to deserialize this, and we need to know which type it is. We need to cast. We use an expression ACC. So now let's go back here. Let's look into our sensor. Here we want ACC. ACC is here. It's a vector 3. It's in this header. So let's copy and paste here. Our output type is vector 3. We need to include this header here. So here we go. Let's select demo model and live runtime and see what we have here. Create a view. Add a scope. Wait till it's finished. Here we go. We see nothing. So, what's wrong here? Let's see. Ha! Here, we forgot our target. Raspberry Pi.car. Stop, start, see if it works now. Yeah, here we go. Okay, let's do some even more crazy stuff. So, I'm on fire. Let's set the LED we have just seen here. So we copy this one to here, and let's use some UDP for that. UDP send, no, receive. And I'm lazy, I don't want to cast and set up the blob we want to send, so I use the serialization once again. Deserialize. Okay. Oh, now cast me. We need the cast. We use expressions for casting. So here we go. Cast me. We use double. What the heck? Okay. So start, stop. Oh, forget the port. We use another one here. 1, 2, 3, 4, 6. Okay, here we go. Now we need to send something. So what do we do? Okay. So we have here, it's already running. Let's set the LED when the ACC X is positive. So ACC.X is bigger than 1, 0. So here we go. We specify our output type to double, that it's the same. Serialize, send via UDP. That's a good thing about UDP, is that we don't need to put this into packages, because every packet is sent and received in a whole packet, not like TCP or SPI or UART or something like that. UDP is pretty easy for that. So here we go. We send it to Raspberry Pi local. So let's see if that works. First, here at our local thing, look what we've got here now. Let's do the scope. And this was x1, x1 out, 0, 1, 0 works. So now let's go here, see what we have here. Scope, take another scope here. No, scope, 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 scope. Add another scope, and we have, where did we put it? Let's take GPIO. GPIO input. That also works. So now let's look here at the webcam. On, off, on, off. That's it. I hope you enjoyed it. Thank you very much. Bye bye.